What's going on, guys? Let's do this problem right here. The question is asking three capacitors are connected as shown in the figure. What is the equivalent capacitance between points A and B? So let's see how we can find this one. So first, when we have problems like this, we start from the end and let's try to compress this one. Like these two are in parallel, right? So we can just directly add them together. So here I can redraw this one as 2 microfarad, 2 microfarad, and these two are in parallel, so I can add them together. When they are in parallel, we just directly add them. So here we are going to have 10 microfarad, right? And this is going to be A and this is going to be the B. Now to find the equivalent for this one, now this is in series, so now we have to use this equation. 1 over C equivalent is equal to 1 over 2 plus 1 over 10, right? Now this is, if I take the common denominator, that's going to be 10. If I take 10 to common denominator, this is going to be 5 plus 1, right? So that's going to be 6 over 10. And that's equal to 1 over C equivalent. So this is equal to 1 over C equivalent. To find the C equivalent, we just have to flip it. So C equivalent is going to be 10 over 6. And if I divide 10 by 6, this is going to be 1, 6, 4. So we know that's 6 right here. And 36, so this is going to be 4, and it just go on and on and on like this, right? So we can say the equivalent C equivalence is equal to 1.667, and that's going to be the final answer. And this is in microfarad, right? And let's look at the second question. Second question is asking 6 microfarad parallel plate capacitor has a charge of 40 microcoulomb and negative 40 microcoulomb on each plate respectively. The potential energy stored in this capacitor is what? So that's the question. So we know that potential energy potential energy is equal to half QV. So here we are dealing with capacitance and charge. So we have charge, but we have to change this one in terms of capacitance. So we know that with the basic equation, that's Q is equal to CV. So from this one we can rearrange this and make V is equal to Q over C. Now if I plug this one instead of Q over C, that's going to make everything in terms of charge and the capacitance. So let's rewrite this. So this is going to be half Q square divided by C. Now we know that half times Q square is going to be 40, so 40 square divided by capacitance, that is 6 microfarad. So this is going to be, so we have micro right here, 10 to the power minus 6. So since we are squaring, we have to be careful about this one. So we have micro, I make this one into farad. So this is going to be 10 to the power minus 6 square root, right? Since I'm squaring 40 times 10 to the power minus 6 square. And in the bottom we have 6 microfarad. So 6 times micro is 10 to the power minus 6 farad. So this is coulomb, it's farad. So we can cancel this one of this 10 to the power minus 6 with this square. And here we have 1600 divided by 12, 2 times 6. So I can cancel this one. This is going to be 800. This is going to be 3, 400. So 400 over 3. 400 over 3 is what? 400, 3, 1, 3, 1, 0. That is equal to 3. Then again 9, 1, 0. So it's going like 133, 333, right? So the answer for this one is going to be 133 microjoule. So that's the answer for this question. And that's how we do this kind of problems. I hope you guys found this video helpful. See you next time.